This is Honors Geometry Lesson 6.4, Proving Triangles Similar by Angle. So if you remember proving triangles congruent, we had a list of 5 shortcuts. And angle was on our bad list. Now for similarity, angle is on our good list. And we don't need to mention that third angle, because if we have 2 angles of one triangle congruent to 2 angles of another triangle, we know that third angle has to be congruent. That's called that third angle congruence theorem. So that third angle is redundant, so we don't bother saying it. So if we know that 2 angles in this triangle are congruent to 2 angles in this triangle, we know those 2 triangles have to be similar. And so right here you can see we have angle, so we know these 2 triangles are similar. So they're asking us to set up a similarity statement. So I can see angle A goes to angle F. I could see angle B goes to angle E. And finally I can see angle C must go to angle D. Now they're going to set up the sides. They're saying side BA goes to side EF. They're saying side AC, the bottom of the big triangle, is to the bottom of the little triangle, which is FD or DF. And then finally, the third side, CB, goes to DE or ED, whatever you want to call it. Then they're helping us set up the proportions to solve for X and Y. You can use their shortcut, or you can come up with your own proportion. I think they're saying bottom of big triangle is to bottom of little triangle, as left side of big triangle is to left side of little triangle. You cross multiply and divide. Let's see, what's that going to be? 300. And you see that y must be y must be 20. Okay. And the same thing over here. They're helping you set up the proportion to solve for X. So it looks like they're saying left side or right side is to bottom as right side is to bottom. You could use their proportion, or you can set up your own. You could say bottom is to bottom as right side is to right side, or bottom is to right side as bottom is to right side. Either way, you'll end up with the correct answer. And 25 times 18 looks like 450. Divide each side by 15. Looks like X is going to be 30. Okay, now they want to know, are the triangles similar? And we only have one way today. It's angle. So we have to get 2 angles congruent. So right now we have a right angle and a right angle. So we have one of our 2 A's. And it looks like 48 and 42 don't match. But just in case, let's find that missing angle. So I'm going to take 90 plus 48, get 138, 180 minus 138. It looks like our missing angle is 42, and boom, there you have it. We have angle. So these 2 triangles are similar by angle. Now they ask us to write a similarity statement. That means match the letters up. So I can see the 48 goes to the 48. This is going to have to be 48. So G goes to L. I can see the 90 goes to 90, so H goes to J. That is, yeah. H goes to J. And finally, the F must go to the K. And there's our similarity statement. For the second one, just like we did in proving triangles congruent, soon as you see vertical angles, you're allowed to mark them. And they each have a 45, so there you have it. We have angle. So it looks like N goes to Z. It looks like Y goes to Y. And finally, M must go to X. This one, we have a 35 and a 35. The 85 and the 65 don't match, but let's just find that missing angle just in case. So we have a 35 and an 85. So that looks like, 120. That looks like this angle must be 60. Doesn't look like they're matching up, so this one we're going to say not similar. Let's look at a couple trickier ones. We have a 65 and a 65, that works. We're looking at little triangle here and big triangle. And you can see they each have a 65 and they each share angle C. So it looks like we're going to have angle, angle. So the big triangle, our A goes to our B and our little triangle, the 65s. Looks like C is going to go to C. And it looks like E goes to D. This one, at first glance, it doesn't look like they're going to be similar. We're comparing this triangle to this triangle. And they both have the 85. They share that. So I'm going to find out what this missing angle is here. I'm going to take 85 plus 65, 150, subtract from 180. We get 30. Wait, I think I added wrong. Yeah, that should be 130, I'm sorry. And so 180 minus 130 gives us 50. Boom, I think we do have angle, angle. It just looks like it's twisted, and then this one must be 45. If we take 50 plus 85, subtract from 180, you get 45. So these two are similar by angle, angle. And let's just match them up. The 50 goes to the 50, so the W goes to the Z, and they both have 85, so Y goes to Y, and it looks like the 45, which is X, is going to go to the, let's try that again, the 45, which is X, is going to go to the 45, which is U, and we say that they're similar. Okay. We see we have parallel lines. You know, if you have parallel lines, you're looking for alternate interior angles, or in this case, corresponding angles. So we know L is congruent to M. If we use this as our transversal, we can also say that Q is congruent to P, and they both share N. So it looks like we do have our angle, angle here, and you just match up the letters. All right, let me do a couple word problems with you. So the first one you're going to see using angle, angle is the shadow of a tree. So they're saying that you're 5 feet tall and you cast a 7-foot shadow. At the same time, a tree casts a 42-foot shadow. And so you can see you have similar triangles. They both have 90-degree angles with the ground. The sun is hitting them at the same angle, so we have angle, angle. So you could say you are to your shadow as the tree is to its shadow. Cross multiply, and I believe the tree turns out to be 30 feet tall. Another thing you can do is place a mirror between yourself and the object you're trying to measure. And then you walk backwards until you can see the tip of your shadow, or I'm sorry, tip of your reflection and the tip of the building's reflection in the mirror. So again, you have similar triangles. They both make 90 degrees with the ground, and they both are hitting the mirror at the same angle. So they're saying this young lady is 5.7 and she's 8 feet from the mirror. And the building is 46 feet from the mirror. And the question is, how tall is the building? So you would say 5.7 is to 8 as X is to 46. Height is to distance as height is to distance. You could say height is the height as distance is the distance. You'll get the same answer. And last one I want to talk about is when the triangles are overlapping, you can stand in the shadow of the tree, and you walk until the tip of your shadow and the tip of the tree shadow are overlapping. They say you're 30 feet from the tree, so this is 30. You're 8 feet from the tip of your shadow right there, and you're 5.6 feet tall, and the question is, how tall is the tree? But just be careful here. This is the most commonly missed one, because people want to compare a triangle to a trapezoid. You can't do that. You're comparing little triangle to big triangle. So this is 8, this is 5.6, this is x, and be careful, you want to add that 30 and 38, 30 and 8 together to get 38. And so we're going to say x is the 5.6, as 38 is to 8. Height is the height as shadow is the shadow, or you could say height is the shadow as height is the shadow. Cross multiply, you'll get the height of your tree. Please try the practice exercises and let me know if you have any questions. Thank you.